Hello. So our 453 final project is a MyoboticArm, and we use the EMG sensor to classify human hand movement, and then we reproduce that gesture through our robotic arm we made.
This is our robotic arm, which is open sourced. So we 3D printed it and assembled that with some errors and imperfections. We already fixed that. So it is capable of the full 5 fingers movement and plus the wrist movement. So next, we are going to show the integration of the system to show how this system works. So now I'm going to briefly explain the hardware, um, which is the PCB basically. So for EMG sensor signal conditioning board, we have firstly the 2 differential input from the EMG electrode and 1 input for the reference voltage. This is 2.5 volt biased, and the signal range is 0 to 5 volt. So the amplification factor is around 250. So after the differential input signal, then we do the rectification and smoothing. That will make the signal better. And for the servo control, we directly interface the GPIO with the logic level shifter to transfer the 3.3 volt signal to 5 volt signal to directly control the servo. The power source, which is used to power on the MG interface, and we have the power board to power the motor logic level shifter.
Okay, so this is a functional block diagram of our system. So the PC is gonna have the GUI interface that the user can click the GUI to train and then classify each gesture. And then the MCU is gonna get the signal from the external GUI interface, and then it's gonna sample the ADC at a 1000 Hertz signal, and then it's gonna port that data to the DE1 with the serial interface, and then the same exact data is gonna be ported to the PC so that the plot can be outputted, and then the actuation can happen through the DE1. The software part of the system uses a Python scikit-learn library to do a machine learning algorithms. And then we're going to use a supervised learning method, which means that we have to pre-train the each gesture with the data. And then in terms of algorithm, we're going to use a k-nearest neighbors, SVM, and the decision tree algorithm. As I said before, the sampling rate is going to be at 1000 Hertz because the meaningful data is between 0 to 500 Hertz signal. And then the basic time domain methods such as windowing mean, kurtosis, and standard deviation is going to be used as a feature. Okay, so this is our GUI interface, and we're going to train each 4 gestures 3 times. And then every time I click this button, it's going to train the gesture and then output a graph. So right now we're going to train gesture number 4, which is the still hand. And then as you can see, it outputted the data in a CSV file format, and then it outputted the plot as well. And then we're going to train this 2 more times. And next we're going to train gesture number 1, which is going to be a holding motion. And then as we previously trained gesture 4, we're going to train it the same way 3 times. And in a similar way, we're going to train gesture number 2, which is going to be just a 1 movement of a finger. last gesture we're going to train is the wrist movement. So after we're done training, we're gonna classify his gesture, and then I'll put that same gesture on the robotic arm.
Wrist motion. The ring. The relax. The hold. Relax.
Our project successfully meets our initial requirements. It performed 4 gestures correctly with human muscle control. However, with the limit of using only one EMG sensor, it is hard to detect more subtle movement of the hand. This concludes our project video for ECE 453. Thank you for watching.